Hello friends, welcome to a new session of the data science application design using Python programming language. In this video, we are going to see the outliers or anomaly detection techniques using Python. Now, so let's have the use of this outliers anomaly detection first. What do you mean by that? In this video, we are going to see this theoretical concepts behind the outlier or anomalies, how to detect that, different ways to detect it, and different ways, different algorithms to remove that anomalies or outliers out of the particular data set. And after this outliers or anomalies are cleaned, then how we are going to make use of this data, clean data, for our algorithms. So this is actually a data pre-processing step. So as we are already aware about the algorithms of data science, this will help you to increase the accuracy of algorithm, to increase or to remove the anomalies from the data set, so that more perfect, more useful, clean data set will be available with us to use. So let's see, what do you mean by outlier? In statistics, an outlier is an observation point that is distant from other observations. The above definition suggests that the outlier is something which is separate or different from the crowd. We just check it out. See the diagram there, they are in sequence. So all we have 32, 33 onwards, and only in that range, only one element which is 3, which is different from the other set of elements. This is what we call as outliers. So see, this is outlier, something different. So when you are going to have, this is what we have plotted for a data set, okay, on x and y, and here one point is present, which is telling that your theory is wrong. So this is outlier. Now an outlier is any data point which differs greatly from the rest of the observations in the data set. Let's see some of the real examples which understand the outlier detection techniques. When one student averages over 90% while the rest of class is 70% only, that's what this student is outlier. While analyzing a certain customer's purchase pattern, it turns out there is suddenly an entry for a very high value. While most of his or her transactions fall below 10,000, his entry is for 1 lakh rupees. It could be an electronic item purchase, whatever the reason, but it's an outlier in the original overall data. Now, our Usain Bolt, the record-breaking sprints are definitely outliers. We are factoring the majority of athletes, and his record is something, the least amount of time which is taken to complete the 100-meter race. So that can be considered as an outliers. So outliers. So there are two type of outliers available: univariate outliers and multivariate outliers. Univariate outlier is a data point that consists of extreme values in one variable only in one variable. Whereas a multivariate outlier is a combined unusual score at least with 2 variables. Okay, more than that also. Suppose you have 3 variables called x, y, z. If you plot the graph of this in 3D space, they should form a sort of cloud. All the data points that lie outside of this cloud will be a multivariate outlier. Okay, so any kind of these outliers are available, and just try to find whether it's single variate, that is univariate, or the multivariate outliers are there. Why to detect the outliers? Now see this one. With outliers, for example, I am working on a linear regression. So when I plot a line like this, when on these data points, so on these data points your line is having almost angle of 45 degrees, almost, not exactly, but just check it out. And the values of this particular line, that it contains intercept and the slope will be different. Okay, so intercept and slope of this line will be different if you are having this one. So just focus on that. This line is averaging all the elements present on this particular plane, but if you consider these are the outliers and I have removed them, so the angle is drastically changed. It is changed almost to 30 degrees, means 15 degrees difference we are getting from this particular outlier removal. Okay, so see, now completely different slope, completely different intercept I will be getting for this particular line when you remove the outliers from the given data set. Okay, that's why outlier detection is very important. Outliers may skew your results, may change your outputs, may increase or decrease, not actually increase, but it will decrease the accuracy of algorithm at the great extent. That's why the data points which does not carry the properties of the crowd, that should be removed. But remember, that should be less number of outliers are present. Here in this example, only 6 points are there out of 50. Only 6 points does not follow the original criteria. That's why 6 are deleted, and we are getting more perfect output expected from the given algorithm. Okay, what did they say? So what exactly the Pierre Lafayette, Marx, author and statistician says about outliers? Outliers are not necessarily a bad thing. These are just observations that are not following the same pattern as the other ones. But it can be the case that an outlier is very interesting. For example, if in a biological experiment a rat is not dead whereas all others are, then it would be a very interesting to understand why the rat is not dead, because there are some conceptions are present behind that and scientific discoveries will be available. So this could lead to a new scientific discovery. So it's important to detect the outliers and find something novel insights in the data set. What are the applications where we can use the outliers? Outliers are used in the fault diagnosis. Why the fault has occurred and what's the reason behind this particular fault? These diagnosis operations are possible with the help of the outlier detection techniques. Intrusion detection, something is like network intrusions. So there intrusions are there that can be detected with the help of this outlier detection techniques. Fraud detections, just like in previous slides I have shown that if a person is purchasing just maximum at 10,000 and at one time we got the purchase of more than ₹1,00,000, so it can be found as a fraud. Can be, possibilities are there. Web analytics, we can do that one. Web analytics, something weird happened that. Medical diagnosis also we can use. Financial industries, very important. Find again, fraud and financial industries are connected together. So there also we can make use of outlier detection techniques so much effectively. And quality control. So you must have some elements which are not following the original criteria. So remove them, make it more qualitative output out of the industries. That's what the applications of the outlier detection techniques, we can make use of them. So wherever the data set is having this kind of the things, so we can make use of the outlier detection techniques, detect the outliers, clean the data, and then make use of this data with the algorithms of machine learning. Okay, so there are 3 types of anomalies that are present. So outliers are also called as anomalies. So 3 kind of anomalies are there. In theory, they are called as global anomalies, contextual anomalies, and collective anomalies. Now, how they are? Check the global anomalies. So global anomalies are in sequence. If a detection of the data is not following a sequence, that's referred as the global anomaly. So this data is not following this sequence. So you are going in this sequence is this is not following it. That's why it's called as global anomalies. Now contextual anomalies are not following a group of sequence. Okay, see the group of sequences, just you can find it, the first sequence, then second sequence, third sequence, and next time this is extra added in this particular sequence does not follow the group of sequences. That's what we call as the contextual anomalies. And the third is called as the collective anomaly. Collective anomaly means a group of elements does not follow the criteria of other huge group of elements. This is what we call as collective anomalies. Not a single element, but multiple elements are there present inside it. They are referred as the collective anomalies. And these collective anomalies can also be reduced, removed easily with the help of the algorithms of outlier removal. Okay, so these are different ways, 3 different types of anomalies, 3 different types of outliers available in the data set, may be present in the data set. Now I have created 2 different parts of this particular video. In first part, we are going to see the methods of detection of anomalies, commonly used methods. So these methods already we have seen. So first 3, and the last one is for removal. Oscillation forest as well as the one class SVM is also I'll be showing in this particular video. So first 3 methods I'll be showing for the outlier detection, and last 2, that is oscillation forest and one class SVM, I'll be showing for the outlier removal. So commonly used, we have already seen box plot, histogram, and clustering techniques also. So we'll just make use of them to find the outliers in the data set. So The packages required for us are data analytics, pandas. We are going to make use of NumPy, SciPy. One extra package I'll be using here, Faker, just for practice purpose. I've just added this package in our session. We can use data set directly, but Faker is used to create the random set of elements, random data set. To do this one, we are going to make use of a Faker package. And to visualize your data, we are going to make use of the Matplotlib, as well as I'm making use of Seaborn package also. So these packages are required to work with the outlier detections now. The first I'll show how to detect or view the outliers, how to replace that. That also the techniques available. That also we are going to see in this particular video. So let's go for that. Okay, so first of all, let's detect the outliers. Okay, so yes, let's read pandas, NumPy, Matplotlib. So all three packages I'm just importing from here. I'll be using one ggplot method of PLT, so that my graphic visualization will be good and more interactive. This is what I'm using. Now let's use of the Faker. So Faker is a package. You just have to install that by using the command sudo apt, not apt, pip3 install Faker. Okay, so Faker can also be used. So Faker package contains a Faker class. This is the Faker class which I have imported from the respective package, and its object I have created over here. This object I am creating for the Faker package. And then I need to I want to generate some set of names, some random names. So for that purpose I'm keeping a seed point 4342. Any seed point can be taken. I just taken 4342, from where the random number generation is possible. And there is a list which is empty list, names list I have created. Inside this list I'll be adding one by one name generated randomly with the help of a Faker package. Okay, that's why this list I have created. Now for data in range 100, so I need 100 names, and along with that 100 salaries also I'm keeping. I'm just creating randomly here without using any data frame, without using any CSV file over here. That's why I just created using this Faker package here. Now for data in range 100, so 100 names I require. So that's why to iterate that particular for loop for 100 number of times, I'm making use of this statement. Then names list dot append Faker dot name. So any random names are generated, and that will be stored into the names list with the help of this. So 100 random names are generated, and they are stored inside this names list. So let's see whether this names list is having any. Just a minute, just say this one. This is what we have, names list. Okay, check this. Okay, this is random names generated out of the Faker's names, and all they are connected to the names list. 100 names are there. Along with these names, I'll be adding the salaries also. To do these ones, I'm making seed point for number randoms, randomization of numbers, np.random.seed for any seed point can be kept. And now I'm creating one salaries variable here. Okay, and by using a for loop for 100 number of iterations, np.random.randint any values between 1000 to 2500. Okay, minimum value 1000, maximum value 2500. Any random value between this range I'm generating, storing in salary, and then I'm appending this salary to this salary variable. So again 100 different salaries are generated. If you see what are the salaries are there, okay, salaries, these are the 100 different salaries generated, which are in the range of 1000 to 2500 only. Okay, 100 salaries are generated, and now we'll combine them together like this. Okay, create a data frame where the names is the first column, salary is the second column, and that data frame will contain the name of the people and the salaries like this. So first column name I have generated using a Faker, and second I have generated using np.random. Okay, so randomly generated values, salaries are assigned to the respective names. Now this data set does not have any outliers. Why? Because we know that names, okay, they are string, that's why they will not be outliers. Salary can contain outliers, but salaries are within the same range, that is 1000 to 2500. So range is common in all total 100 entries from 0 to 99 they are created, and the salaries are defined. Now let's add the outliers by our own. Okay, now let's see. Now df dot at 16 number position salary, I'll be keeping 8967, which is very higher than the other salary 8967. At number 16 I'm adding, so using at function I'm adding the salary, and by using 81's position I'm adding salary as 7300. Correct. Now check this out. Okay, so this outliers I have added by my own. See, 16 number salary is William Young salary I've changed 8967, and 81 salary also I've changed 7300. Okay, these are the use of the at function. Done. And now let's make use of a box plot. Box plot is very commonly used method to detect the outliers. Let's see this one. Salary dot plot kind is equal to box. So box plot I am making use of it here. See this one. So this is your salary, only a single column, and these are the values of salaries. Now you just can check it out here. So the range is from 1000 to 2500, and this is the median of all the values almost. Okay, see this one, almost 1700 or something like. And these two values, these are the outliers. This does not follow the pattern of the crowd. That's why they are considered as the outliers. So this is how outlier can be detected easily with the help of the box plot. So two outliers are there that we can find, and their values are also almost approaching towards 9000 and 7000 that you can find. And we know that now values are greater than 2500, so which are greater than 2500, either delete them or replace them. That's also we can make use of. Or see, let's use the box plot method from the from our matplotlib package. So here I am using from pandas package, that is data frames plot method, and this is your matplotlib's plot method. Almost similar kind of output, only color coding is different. Output is same. Now let's use one more method, histogram, the second method to detect or view the outliers. So here I'm using df of salary dot plot kind is histogram. So as we know, histogram is a frequency plot. So how many elements are lying within a specific range, that can be shown with the help of the histogram. So histogram will show you this. See this one. This is wow. So you just can check it out. From 1000 to 2000, this number of people are having salaries. Means almost 60, 58 something. This number of salaries are there, and from 1000 to 2500 something, 1500 to 2500 something, almost 42, 43, 42 people are having the salaries. Okay, and one people having salary in the range of 7000, and one people is having salary in the range of 8000 to 9000. Yes, now these two are the outliers. So by using the histogram also we can make use of this technique to find the outliers. So histogram can also be seen, so you just can find this box plot and the histogram. So let's check the length. Total 100 elements are present over there. Now the third method, clustering. We have already came across the concept of k means clustering. We know that we have to give the value of k, and based on that we are going to create the group of people inside it. So here I'm using the k means from the scipy.cluster.vq. Okay, same algorithm is there, only the location of package is different. So let's see how to do this one. Okay, so first of all, convert the salaries into numpy array. This one, they converted into numpy array. We know that if you attach this salary, this is a series object, and dot values will convert that into numpy array format, that is salary raw. Okay, and then to maintain the compilatory scipy, I'm just changing that one dimensional array into two dimensional arrays into column vector. We already seen this also in linear regression, -1 1, by which we can convert this single dimensional array into multi-dimensional arrays by reshape. Okay, data type is also changed to float 64. Okay, now we got that salary raw with us from the original salary values, and now let's create the clusters. So from scipy.cluster.vq we are importing the k-means algorithm there. Okay, and one more cluster object I'm reading from the respective package. Okay, so they are imported. Let's see now. K-means, so two parameters which are expected. First parameter is the values which we are going to plot, and second parameter is the number of clusters expected. So for example, I want 4 clusters to get out of it. Just randomly I mentioned that 4. I can mention 3, 2, 1, whatever you require. So 1 is not expected. At least 2 should also be there. Centroid, average distance. Okay, so it returns 2 values, centroid values here and average distance from the center of this particular point that also we have seen. Okay, that is returned here. So these 2 are returning. Then get the groups and clusters and distances. So all the groups, their cluster distances, we are going to get by using this method, cluster.vq.vq. So salary raw I'm providing, and the centroid which we got from here, these are provided here. So it will return these centroid distances and the groups which are from this clustering. Okay, it's returned. Now let's plot that. We got the clusters, we got the numbers, and now we plot this one. pld.scatter salary raw np arrange 0 to 100. So on x side we are going to have the raw salary, on y side we are going to have a range, the range of element from 0 to 100, and how many groups you want, that is also mentioned here. Maybe it contains the 4 groups which start from 0, 1, 2 and 3. So wherever the point is coming in zeros cluster, their color will be same. One's cluster color is same, 2 cluster, 3 clusters. So based on that cluster, the colors are assigned to it. Okay, so on x side we have salaries, and on y side we have the indices. Let's see this one. So I got 4 groups here. This is the first group, second group, this is third group, and this is the fourth group. Check it out. The fourth group is having only 2 points in it, and these are the outliers present in this particular data set. Okay, now this is how the k-means clustering can also be used to detect the outliers. So what I'll do, I'll just make these changes here. I'll make it this 2. What? The number of groups or clusters expected, I'll make it 2. So let's run this. Now see this one. Now these 2 points are coming in this part here. It's not showing correctly. Clusters are present but not showing correctly. I'll make it 3. Yeah, now this is fine. A group of these 2 is there only, group of this and a group of this. Clusters are forming correctly, but one group of clusters is the outlier group, and that outlier we can remove by some methods. Let's see how to remove the outliers by using some specific simple statistical methods, and then we'll go for the standard algorithms used from machine learning. Okay, first method is trimming. Directly trim the values. Now you can just identify here, maximum salary here is not greater than 300, so 3000. So you just directly trim the values which are above 3000. Okay, trim the values which are above the 3000. So how to do this one? So let's see. New df of salary greater less than 3000, only they are extracted and they are stored into new df. That's what trimming means. The values whose salary is greater than 3000, that will not be considered here. Yeah, this is done. And now see the plot. Yes, nothing, no outliers. Minimum value is 1000, maximum is almost 2500, and all values are lying within this range. And if you see the length of df 98, 2 outliers are removed out of it. This is manual trimming of the data. Trimming of the data from the data set is possible by this particular technique or this particular method. Okay, trimming. Second is what we call as quantile based flooring and the capping. Now quantile based is top 10% or the 90%. These values I'm taking a quantile from there. So this one's a statistical method that's applied here. df of salary, 10% quantile and 90% quantiles. These 2 values I'm extracting. Okay, so 10% top least 10 and highest 10. That's what we are going to make use of it here, flooring and capping. Now that's done. By this method we'll be getting the 10% quantile is 1163.6 something, and the 90% quantile I'll be getting 2346.9. Now what we are going to do now with this quantile we are getting over here. Now let's create a copy of this data set ndf, and now let's replace the salary. If the salary is less than 1163.6 anywhere. Okay, so what's the meaning of where function here? 3 parameters are passed there. If this condition is true, then this value is returned, else this value is returned. That's like if, then and else. Now if the salary is less than 1163, means less than the 10% of this quantile, then replace this value, else keep the salary as it is. Means if it is containing, for example, 900, so 900 will be replaced by 1163, 1000 is also replaced by 1163. So at least 10% quantile you are going to make it, and at max 90% you are going to make it. Means second statement will show you, if the salary is greater than 2346.9, this value I am keeping over here, then keep this value as 2346.9, means outliers are above that, then this value will be trimmed, or they will be replaced by this particular value, else the value will be as it is, like 1400, 500, 600, 2000, like that will be, that will not be changed. But if value is below this or above this, then these values are matched to these particular points here. That's what we are going to make use of quantile based flooring. Now this is changed, and now check this one. Now the values are just matched within the range. So maximum minimum value here is 1163 maybe here, and maximum value is 2346 maximum, and all other values are within that range only. So if it is going high, going above, or going below specific boundaries, then these values are occupied within a specific range, and that's what we are going to do here. We have not done any trimming, means the outliers are not deleted, outliers are present, or they're replaced by the specific values within a range. Okay, the length is 100. And the third method to replace, that is replace the outliers with the median values. Median means the middlemost values. Okay, that also we can make use of it over here. So let's see this one. So I got the median, that is quantile of 50. So quantile of 50 will give you the median of values, and quantile 95% means top 5% values will be removed. That's for that purpose I will be making use of this 95% here. So the median, that is 50% quantile, is 1720, and 95% is 12397. So maximum value will be 2397, should be present. So I am keeping a copy of it. Then salary I am replacing. What I am going to do here, if the salary is above 2397.7, then replace it by median, else keep it as it is. Replace it by median, else keep it as it is. So if this, then this, else this, into this, like so. Higher values are deleted only by this. Now see this one. So here maximum value I am getting here is 2397.7, and minimum value 1000, this as it is. So lower values are not deleted, not replaced, actually they are kept as it is, 100. If you see the NDF, wherever the 16 was present, it's replaced by this. See this one. Even 17 also, it was above 23 something. Okay, and 81, just check it, 81, 1720 is replaced. So this is the way how we can detect the outliers as well as we remove the outliers. So these are the commonly used techniques, commonly used ways, commonly used methods to detect the outliers or to replace the outlier by using a specific methods. Okay, now if you go to the original data set, okay, so let's go for the, so these are the techniques that we have already seen. Clustering also we have seen, just try that. Two commonly used algorithms are there. Algorithms in machine learning algorithms, these techniques are used commonly for detecting and removing the outliers also. Now first algorithm is termed as the isolation forest. We'll work these algorithms on the original data set in the CSV file from data frame. We'll read that in, and then we'll see how to remove and use this algorithm for removing the outliers. Isolation forest is an algorithm that isolates observations by randomly selecting feature and then randomly selecting a split value between the maximum and minimum values of selected feature. The logic is like this. Isolating anomaly observation is easier because only few conditions are needed to separate those cases in the normal observations. On the other hand, isolating normal observations require more conditions. Therefore, an anomaly score can be calculated as the number of conditions required to separate a given observations. The way that algorithm construct the separation is by first creating isolation trees, random decision trees, and then score is calculated as the path length to isolate the observations. So how data is actually isolated from the original observation, that score is identified, and based on that score some values which are not following it will be removed. That's what the isolation forest does. Now this isolation forest algorithm is present inside the ensemble algorithm there. So before actually going to implementation, let's see the data set present. So the data set which is present for our case is PMA Indian diabetes. I'm using over there. This is PMA Indian diabetes, very popularly used data set for different kind of machine learning algorithm is that. I'll work this algorithm on this data set specifically, so that we can just remove the outliers from this data, which is multivariate. Okay, remember multivariate, the thing that we have seen, it was univariate previously. Now we are going to make use of multivariate. Now in this is the number of times pregnant, then glucose concentrations, like not many. So it's data set of different pregnant women is taken, and based on that we are going to have the diabetic or non-diabetic classes, 0 and 1 classes present there, and different data that we can find inside it. Okay, so all values are numerical values. Class is the output variable, which signifies 1 signifies diabetic patient and 0 signified it is non-diabetic patient. So based on that these classes are defined, and now we are going to detect the outliers as well as remove the outliers with the help of isolation forest and with the help of the one class SVM. Okay, so this data set we are going to make use of. Okay, so just go to data. Yes, so read pandas. Okay, read the data set now. PMA Indian diabetes. Okay, see the columns which are present in it. All these are columns. Your A class is the output column present inside it. Okay, then after this we are going to drop the class in input variable. Will be making use of here. Let's make use of X. Okay, and Y is class. Fine. If you go to check, 768 number of rows and 8 columns are there in it, in input variables specifically. So in multivariate we are going to have the multiple inputs in collaboration of all together we are going to find the outliers out of it. Okay, so done. Okay, this data set we have imported. Now let's see how to use ensemble techniques, that is isolation forest from this. So from sklearn.ensemble import isolation forest. So import it. Now let's create the isolation forest object. Now isolation forest is the ensemble technique, so that's why we require a number of estimators, number of trees required to give inside it. Number of estimators are 100, number of trees we are giving 100 there, random state I am keeping 0, and its object is ISF I am creating. Create it. Now let's feed the input. So input name we are given is X. This is X input. Apply that just like other machine learning algorithms. To train algorithm with the given data, we'll be making use of the fit function, fit method. So I'm using fit method here. X is assigned. I got ISF again. Then predict now. Now isolation forest will predict the data which are not following the validation score. So pass it there. Clean data set will be available with us, and that clean data set will be making use of. Now what clean will show you? Fit, then predict, same. Now insert. So let's see clean. Now this clean values will contain only -1 and 1. -1 signifies it is an outlier, and 1 signifies it is the data which follows the strategies of a group, similar properties of the group. Okay, this is how this technique is working actually. Okay, so fit and then predict. Remember why predict is actually used here, because if new data comes, and that also we can find whether it is within the range of that multiple variables or not. If it is within the range, we'll return 1. If not within the range, we'll return -1. Okay, so -1 signifies it is an outliers. Okay, so total 768 elements are there, which are 1 and -1 shown there. Check it out. Now I want to find only the clean data, so let's use this one. From X, so I'll be making use of this Boolean filtering technique here. New X is equal to X of clean is equal to 1. Means if this value of the clean data is 1 there, means it is not outlier, I am keeping that into new x, and similar I am doing for the y also. Okay, so because y is also 768 rows, it's present there. So do this one, clean data which are not outliers, that I am extracting from the x, and then I am storing into this. Now see how many entries are there, 658, means out of 768 means 110 entries are deleted. They are considered as outlier by isolation forest. And then the clean data in new x and new y, I got this one. Now same data I can use for other algorithms, like for example I want to make use of a decision tree, I want to make use of random forest or new Bayes or SVM. So you can make use of this data to create a machine learning model of this and do the predictions further. That's possible with the help of this particular technique. Okay, so new x, new y is the removed clean data that I am getting out of it. Okay, so this is how outlier detection and removal is possible. So you just can identify which element is outlier and which element is not outlier by this technique. They are created in a sequence. Make sure that they are created in a sequence, okay, for all 768 entries. Similar to that, we are having one more class, one more algorithm called as one class SVM. So one class SVM is also used to detect the outliers. Means the element which are having common properties, they are given as 1, and not having common properties will be given -1. Okay, so single class SVM, that's why it is called. Now let's look at the implementation of SVM, that is one class SVM. Okay, the problem addressed by one class SVM as a documentation, that novelty detection. This is one of the documentation that we can find in Google also. They have mentioned novelty detection technique basically that in one class SVM is having. This original paper describing how to use SVM for this task, support vector machine for novelty detection. That is one class SVM is. Novelty detections means they are creating a group of the data which is having some novelty inside it. Means the group which is not selected is considered as outlier. That's why one class SVM is used for outlier detection techniques. The idea of novelty detection is to detect rare events, that is event that happens rarely and hence of which you have little samples. The problem is then is the usual way of training classifier will not work. So how to decide what a novel pattern is? Many approaches are based on estimation of density or probability of the data. Novelty corresponds to those samples where the density or probability is very low. How low depends on the applications. Now SVM are max margin methods, that is they do not model a probability distributions. Here the idea is to find function that is positive for regions with high density of points and negative for small densities. Okay, so when high density points are there, it's positive values, means 1 will be present there, and for negative, when the small densities are available, there the values will be negative. So similar idea, positive and negative, this idea is used here in the one class SVM also. Implementation is same. Let's see, I'll use the same data set here to implement it and then perform the operation of finding the outliers. So let's see, from sklearn.svm import one class SVM. Remember, output may be different, it depends which algorithm will be using there. So let's see, so from sklearn.svm I'm importing one class SVM. Okay, then create the object of it and now fit that data to x. Okay, fit it, OCS equal to OCS.fit x, and now predict it just like isolation forest. I got the clean data, and if you see the clean here, so same negative positive values will be available. See, 1 minus 1, here we are getting many -1 actually, not many -1s are there. And now use x of clean equal to 1 and y clean equal to 1, and if you go to check new underscore x dot shape, oh, only 384 entries are there, means less than 50% entries are positive and the others are negative. So maybe we are creating one class for positive entries and one class for negative entries. That's possible. It means that you can easily find which entries are in one group and which entries are in other group. That's possible. So here very less number of entries are taken in support vector machines, one class SVM. Okay, so these are the techniques. Now this data I can use for further machine learning algorithms also. Okay, so these are the techniques which we can use to perform the operations of outlier detection as well as the removal of this also. So whenever in any machine learning algorithms the data that we use is containing the pattern which does not follow the original criteria, you have to remove this data, and after removing that data, your data will be more cleaned, it will be more useful, it will may have more accuracy than the original data set, so that a perfect model of machine learning can be created and you can easily do the further prediction with the help of this data set. Okay, that's it. That's how outlier techniques works. If you have any doubts, questions, the communication ways and methods are given in front of you in this particular video. Thank you. Thanks a lot.